Hi guys, what is the problem with logarithms? Why is it so important to find the logarithms of numbers? I bet many students do not like the sound of the word logarithm. It seems ugly, doesn't it? Long ago, in the 16th and 17th centuries, when there were no calculators or computers, performing multiplication of large numbers was very horrendous. Remember in primary school, when you were to evaluate 2.431 times 3.789 times 5.007 without a calculator. You can remember how tedious it was and how time-consuming it was. The worst scenario was when you made a mistake and the answer was wrong. Very painful, right? This was actually the case with the scientists of the 16th and 17th centuries. The multiplication was slowing science down. Then, a Scottish mathematician named John Napier found a way to translate multiplication to addition, which made multiplication faster. Science became faster. Napier found a way which involved comparing numbers, and he termed it logarithms, meaning ratio of numbers. It was coined from two Greek words, logos and arithmos. He made multiplication easier by finding the logarithm of the numbers he intended to multiply and then summed these logarithms. Then he found the number with that summed logarithm, and that was the product of the initial numbers he wanted to multiply. For example, if he wanted to find the product of 523 and 678, he will easily find the logarithms of 523 and 678. Then sum the respective logarithms. Then he looks up the number that has the sum as its logarithm, and that will be the product of 523 and 678, which is 354,594. This helped to drastically reduce the stress in multiplication. But many scientists did not understand Napier's style. So he drew up a table by which scientists could easily look up the logarithm of numbers. That table is what today we call the logarithm table. The name logarithm is what usually scares students, but it was until about 200 years later that scientists realized that what Napier called logarithms were actually exponents, powers, indices. I mean, simple indices. They realized that the logarithm of a given number x is the power to which another fixed number to the base of b must be raised to produce x. Logarithms can come in any base except 0. But the most dominant bases are the base 10, called the common logarithm, base 2, called binary logarithm and used in computer science, and base e, a mathematical constant called natural logarithm. Now, the question, why logarithms? After 400 years of Napier's discovery of the logarithm, we now have computers to do our multiplication. So why still bother me with learning logarithm? This question may be bothering you. But logarithms are still relevant in our daily life as they apply to the various things that concern our daily lives. For example, the electromagnetic waves that we use to communicate over the phone are measured in decibels, and decibels are logarithmic measures. Sound levels are also measured in decibels. Even in chemistry, pH is the logarithmic measure of the acidity of an aqueous solution. In subsequent lessons, we will be learning how to use the logarithm table to find the logarithms of numbers, and also how to use logarithms to simplify tedious multiplications and divisions. I can't wait to be with you in the next lesson.